Hello, good morning, everybody. I hope you did question number 1, 2, and 3 and practice that. So, today we are going to do question 4 and question 5. These are very important questions. Question number 4, using Euclid's division lemma, show that the square of a positive integer is either in the form of 3m or 3m plus 1 for some integer m. Okay, so the question is using Euclid division lemma, you have to show that the square of a positive integer is in the form of 3m or 3m plus 1. So before we actually solve the question, let me help you understand what is the meaning of this question. So square of a positive integer. Now we know that these are all squares of numbers. 9 is the square of 3, 16 is the square of 4, 5 is the square of 5 square is 25, 6 square 36, 7 square 49, and so on. Now if you look at 9, it is a multiple of 3. Okay, but 16 is not a multiple of 3, but it can be written as 3m plus 1. That means 3 5 is 15, 15 plus 1 is 16. 25, what about 25? Is it a multiple of 3? No. But it is again in the form of 3m plus 1. That is 3 8s are 24, 24 plus 1 is 25. 36 is a multiple of 3, 3 12s are 36. 49 is not a multiple of 3, but it is 3m plus 1, that is 3 into 16 is 48, 48 plus 1 is 49. So this is what we have to prove, that either it is in this form, that is multiple of 3, or multiple of 3 plus 1. So as I told yesterday, for these type of questions, you will have to first say by Euclid's division algorithm, a equal to bq plus r, where r is greater than or equal to 0 and less than b. That's a standard statement we follow in all the questions. Now in this particular question, we have to prove that it is in this form, 3m or 3m plus 1. So if you look at the coefficient of m here, this is 3. So that's a clue of what the value of b should be. So that's why we will take here in this question, let b equal to 3. So whatever is the number here, normally we take that. So we take let b as 3. So what happens? A now becomes 3q plus r, because we are replacing the value of b as 3. So r will be greater than or equal to 0 and less than 3, because we have put the value of b as 3 here, and remainder we know is always greater than or equal to 0 and less than the divisor, less than b, so less than 3. So the values of r could be 0, 1 or 2, cannot be 3 because r is less than 3. Now we'll have to take all these three cases one by one. So case 1, if r is 0. So if r is 0, what will happen? A will become 3q plus 0. So plus 0 is neglected because there's no point in putting a plus 0 there, because the value will not change. So we can just write a equal to 3q. Now as per the question, we have to square both sides. So this will become a square is 9q square. And now this 9 can be split into 3 into 3q square, because the question demands that it has to be in the form of 3m. Now what is important for us is this number 3 that is outside the bracket. What is inside the bracket is insignificant, because 3 into anything will be a multiple of 3. So whatever is here, 100, 1000, 10,000, 1 lakh, whatever happens inside the bracket, the number 3 is important. So whatever is inside the bracket, that can be replaced with m. So m value in this case is 3q square. So you get the first part, that a square is 3m. Now we can repeat the procedure with r is 1. So if r is 1, the value of a will now become 3q plus 1, because we are putting the value of b as 3 and r is 1. Again squaring both sides, a square is 3q plus 1 whole square. Now this is an identity which you have done in class 9. A plus b whole square is a square plus 2ab plus b square. So a square will become 9q square, 2ab will become 6q, and 1 square is 1. Now we can take 3 common in these two. So we get here 3 common, 3q square plus 2q plus 1. And as I explained before, whatever is in the bracket, that can be replaced with m. So m value here is 3q square plus 2q, and we get the value of a square as 3m plus 1. So we've finished the cases of r as 0, 1, and next we'll do r is equal to 2. So if r is 2 now, a will become now 3q plus 2. Squaring both sides now, again a square is 3q plus 2 whole square. Again using the identity of a plus b whole square, a square plus 2ab plus b square. So this will become 9q square. 2 into a into b will become 12q, and 2 square is 4. So we get this, and here there's an important step. This 4 is not a multiple of 3, so we can break this 4 into 3 plus 1. So what happens is when you take 3 common now, this will become 3q square, 4q, and 3 ones are 3, and plus 1 outside the bracket. And whatever is in the bracket, just like before, replace with m, so we get 3m plus 1, where the value of m here is 3q square plus 4q plus 1. So what have we proved? That the square of a number will always be in the form of 3m or 3m plus 1.